In this webcast, I'd like to describe what's expected of you for each mechanism challenge that you submit. As described in a previous webcast, challenges are composed of a problem, a visualization, and a solution, all sort of wrapped up into one nice package. And so, if you look at the template code for your wiki page, under the Mechanism of Action section, you'll notice two important subsections related to challenges. One says mechanism-based challenges, and the other is visualization-based challenges. For a mechanism-based challenge, the idea is that you'll use a Marvin sketch image as your foundational visualization here. As an example, I'll use the visualization that we created in the previous webcast on working with Marvin sketch, which was related to the concerted versus polar mechanism of the Diels-Alder cycloaddition that we investigated. And so the essential problem here, the question that I would place inside this info box, is about the two possible mechanisms and which one is better supported by experimental data. And so essentially, we can type that out in question form, and that forms the basis of our challenge question. There are two possible mechanisms of the Diels-Alder reaction. Which one is consistent with experimental data, and why? In the area below the info box, where the question or problem is provided, you'll provide the visualization along with some explanatory text. I already have the code from the visualization that we created in the last webcast available on the page, and so I'm going to go ahead and grab that and just place it in here as the first thing right below the info box that contains the question. You can see it's still titled Concerted versus Polar Mechanism, and it's still linked to that visualization that we created using the Marvin sketch interface. Now below that, the text that you provide here should clarify and explain what's in the image. So obviously within the image we weren't able to include all the relevant experimental details. Notably, the rates that were mentioned in a previous webcast weren't included there. All that we said was that the mechanism involving the polar intermediate was unsupported by the experimental data. So within this explanatory text, I would put things like potentially an image or a table with those rate numbers or qualitative values like fast and slow, as well as explanatory text describing the reason why the results support the concerted versus the polar mechanism. You can also provide some additional details here. So if there was another study that we came across that supported the concerted mechanism, such as a molecular orbital study or something like that, we could provide that in this explanatory text as well. What you want to be sure of is that your text fleshes out the visualization as much as you'd like it to, and brings to bear all the language of Chem 232 and 332 that you'd like to associate with the visualization that's not already within it. The last thing to note about the mechanistic challenge that we've worked on so far is that it's a very specific question about the mechanism of one transformation. There's a temptation to develop challenges that are very broad and that don't focus on the actual bonds, atoms, and covalent change associated with your topic, but it's important to remain very specific when you develop mechanistic challenges, because that will maximize your chance of success in terms of developing a convincing argument for the mechanism that you're trying to support. The broader you get, the more moving parts essentially there are to the mechanism. And so be careful to focus in enough that there are a small enough number of moving parts in the mechanism that you can negotiate those effectively and build a sound scientific argument based on evidence that's available.